Hello. I'm going to go ahead and test some of these things. Yeah, no worries.
Hello. Hi, Abby. Sorry about the little muting. I just got pulled into a quick call and I just had to wrap that up. But how are you?
Oh yeah, no worries. I'm doing well. It's nice and bright and early over here and in San Diego, so it's been a good morning.
I do love San Diego. It's one of my favorite places. Is that where you've lived for a while?
Yeah, I was born in San Diego and I've stayed here my entire life. I went away for school and then I came back.
Did you go outside the US?
No, I went to LA.
Okay, so not
Yeah,
too far.
not too far.
Which
No.
what do you think of LA? I'm sure you'd been there before, but what do you think like living there?
Well, I lived more in Orange County, but I
Uh,
went to school because I went to Cal State Long Beach, so I was more in the Long Beach area, not deep LA. And when I would go into deep LA, it felt like a lot of cars. I mean, I do come from a city, but LA, like downtown LA, is a whole other level.
yeah, downtown LA is
Yeah.
it's kind of crazy. Orange County is great. I
Yeah.
like that side of California so much better than, I mean, personally, I think LA is like, I mean, I say overrated is like not really the right word because like
Mhm.
it depends on your expectations. But I think my cousin was at SciArc in downtown LA doing her architectural master's degree.
Mm.
And so I'd
Mhm.
go visit her and I was just like, "Oh, I don't know, something just didn't feel right." And then one of the times I was visiting her, I like was like, "Oh, I could take this train into San Diego. I've never
Mhm.
been." And
Yeah.
once I got to San Diego, I was like, "Oh my God, this is what I thought LA would be like. This is like for whatever reason, this is what I want expected." And then
Yeah.
San Diego became like my favorite place.
Oh, are you on the East Coast?
I was born and raised in Vancouver,
Mhm.
but I'm in Toronto right now. Um,
Okay.
so I'm
Yeah.
going to be in Toronto only for another, well, technically I'm going, it's a bit of a busy couple of months. Like I'm going to be
Mhm.
in New York
Oh.
and then Montreal, then back in Vancouver for a couple of weeks before I'm in Asia for a month, in part for DevCon, and then just kind of
Mhm.
traveling and meeting my family in India, and then back in Vancouver for a month before I'm back in Toronto in January. So it's going to be a lot of like planes.
Yeah, I'm noticing that. But you'll get to see friends and family and experience new cultures and food. I always like when I visit places like, ooh, what is there to eat? That's good. And
Honestly,
yeah.
you're my kind of gal. Like 50% of like the reason I pick a place is like, ooh, food. And the other
Yeah.
50% is like, is it like, well, I'd say the other 25% is like the walkability of the city
Mhm.
so that I can like just navigate, explore, have like patio drinks and see cool things. Like,
Yeah.
my personal like pet peeve when traveling, and I know some places it's just the way it is, but
Mhm.
I hate being in a car so much. Like, it's
Yeah.
where most of your time is traveling to a place that you're at for maybe the length of the car ride, um, or sometimes even shorter. And you just think, that's really not what I want to be doing on my vacation. So
Yeah.
yeah, Asia's good for that. I mean, it's got traffic, but yeah, it's all right.
Yeah, you'll be able to travel probably by, walking or just a little bit by car.
Yeah, or sometimes I think transit. I mean, I'm not in India. I don't know about Mumbai and Jaipur. I think I'll just be in a car, but
Mm.
not too bad.
I was wondering if I play this audio right here of this
Yeah,
video, if it goes through to you.
yeah. Go ahead.
Let me go ahead and try that.
Hello, I'd
Do you
like to
want to
talk
hear
to you
that?
about
Yeah,
how the hash graph
Okay,
consensus
awesome.
algorithm works.
yeah. Perfect. That's great.
Okay, cool.
I got a little sneak preview of some cute puppers. How
Oh yes, those are my dogs. I have a
many do
lot.
you have? Four?
I have four, yes.
That
Between
is
me and
amazing.
my husband, we have because I came with two, and then when I met him, we found a dog, and so we had three, and then when we moved in together, we got another dog, and now there's four.
I think that's the answer.
Yeah,
Absolutely love dogs. I
they're
don't have
amazing.
one right now, but I am basically just like, because I've been traveling so much that I'm like, I need to settle down, pick a place, and then I can get a dog. So maybe next year.
That would be exciting.
I know. I grew up with dogs. Like it's like strange not having a dog in the house. Like we have one at my family house, but not where I am.
That's kind of how I felt, and I think I overdid it with 4.
Well, what's another bowl? What's another bowl of puppy food?
I know, right?
Nice, nice. So just to give you a little breakdown of how this will go. So
Mhm.
I mentioned in the email, I'm just going to do a very quick introduction about Builder and share some resources from our end, which is like developer docs, which are a combination of all the different workshops we're hosting this series,
Mhm.
including yours, and then the submission form. And so once I do that, which will like take less than 5 minutes, I'll pass it off to you, and you'll have the rest of the time. So we have up to an hour, so you can take your time. You can, depending on your format, you can answer questions in between as they come, or you can answer them at the end, or just move them all into Telegram. So I kind of leave that to your discretion,
Okay.
and it feels like the best way to teach for you. And yeah, that's basically it. We give everyone a week to complete the assignment. So once we are done this, I'll edit this to only include the presentation part, share it on our YouTube, reference it. There'll be questions coming in, I'd say throughout the week here and there, but the dedicated office hours are just immediately after the workshop.
Mhm.
But if you can check in and respond, and if there's any resources you can share that people can reference, that's usually pretty helpful.
All right, sounds great. Thank you.
Cool. Hi, everyone. I'm going to get started on just the builder presentation of things. And then we'll pass it on to Abby to continue on with the workshop. I'll still be letting people in as I'm presenting. So in case you hear a little beep, that's what that is. So yeah, welcome to our workshop. Really excited to have you all here. This is our team. We've spoken to a few of us through our various communication platforms. Of course, we are committed to bringing free education in the blockchain space to our community. And in doing so, we also like to be able to provide crypto rewards for completing the learning outcomes. Today's workshop is possible through Hedera. We have Métis, ZKM, and Alio as well for this workshop series. So hopefully everyone has a chance to check all of them out. All the recordings will be available on YouTube, and the educational side of things is always free. Reminder that for you to be eligible for the rewards, you need to have been approved for the workshop and attend the workshop live. This is to ensure that everyone has access to the workshop walkthrough and is able to participate fully. So this is our resources here. So I've dropped this in the chat, and it's also in the Telegram group where we'll have our office hours directly after the workshop. So the developer documentation is the resources you need to complete the learning outcome. Abby may share some additional resources, which if they are dropped in the chat, I'll also add in Telegram. And then this is the QR code for the submission form. This is how you complete, and this is where you submit your completed forms. You have a week from today to work on that. And then the Telegram group is for office hours that are immediately after, as well as support from peers and other folks who are familiar with the blockchain as well. So I highly encourage you to share your learnings and support people as you move forward in your blockchain journey. And so without any further ado, I will pass it on to Abby. Thanks, everybody.
Hello, thank you. Let me go ahead and make sure that my screen is being shared. There it is. All right, well, thank you everyone for being here today or this evening, depending on where you are. This workshop is called Building on Hedera, an Introduction for Developers, where you will have your first steps in Web3 development with Hedera. Let me go ahead and introduce myself. My name is Abby. I'm a developer relations engineer at Hashgraph for Hedera. My background is as a software engineer. I studied computer science, and then after some time in software engineering, transferred into a developer relations role. I'm really excited to be part of this workshop as an opportunity to be able to talk more about Hedera, more about blockchain as a whole, Web3, as it continues to change and shape our future. I really love to connect with developers, non-developers, so you can see some of my connect with me links. There's a Twitter one and a LinkedIn one, so feel free to connect with me on LinkedIn. In addition to that, these are my 4 amazing dogs that I own with my husband. In my upper left with the ball, you have Charlie. Upper right, we have Nori posing for a nice sunset picture. And then we have Luna, my husky, on the lower left. And Snuffles in his Christmas shirt on the bottom right. They keep me very busy, but very happy. So let's get into the actual presentation. So we're going to start first trying to understand Web3. And in order to do that, we should think about how we organized our lives up until this point. For thousands of years in the past, like pre-1970s, we had the analog era, which was where everything was tracked on paper. But this meant that there was limited access to that information as all of that paper stayed in that location. Was not easy to share. But if you fast forward to the 1970s, where we entered a digital era, this was fortunately when we had the computers and mainframes, and we were able to automate some tasks, and we were able to gain speed. As time went on and we reached the early 2000s, we had reached the internet era. This was early 2000s, where we were able to now have open access to information. We were able to collaborate with other people around the world. And in addition to speed, we were able to gain access and collaboration. Now, during this 2000s era, the internet was great for information exchange, but not really for value. And what I mean by that is that it wasn't simple to pay someone for pizza online. It was more just static images, static pages, and this is what we can consider Web 1.0. The creators of these static images were developers and those who had specific knowledge of how the internet worked during that time. As technology kept evolving, still within the early 2000s, we arrived at Web 2.0, which is when the web became a lot more interactive, social, and mobile. You had things like MySpace, and I'm not remembering anything else other than MySpace, but I'm sure there were other things. And you didn't have to be a developer. I remember being able to create HTML and CSS and not having any knowledge of what I was doing. This is what what created that interactivity, that mobility, that availability. But in addition to all of that, there were some valid concerns that revolved around the trust and access control, data ownership, especially when it came to large application creators. This is where we became concerned about our privacy. So around 2009 is where we entered a trust era to address some of these issues. And that's the foundation for Web3 that is being built today in front of our eyes, where things like decentralization are at the core thanks to decentralized networks of peer-to-peer networks. And so another way you can look at this is Web 1 was you could read things. Web 2.0 is you could read and write. And now Web 3, you could read, write, and own. That's sort of a smaller breakdown of all of that. But this whole evolution of web is important because it's a tech that impacts everything that we do. And at the core of this evolution are distributed ledger technologies, or what are known as DLTs. And that's what I want to get into next. DLTs are these peer-to-peer networks where multiple members or nodes maintain their own identical copy of a shared ledger. So you can see in this visual on the left that there is an entire network that verifies, executes, and records each transaction without relying on a middle person, also known as, like, this is this decentralized network. Like, this network is decentralized. The entire network records and it validates each transaction. In contrast, on the centralized ledger, this will require a central authority to update and communicate the records to all participants in the network. The decentralized networks have this consensus mechanism, which you can think of as rules for updating a ledger. And these rules are usually determined by a governing concept of some sort. And I'll get into the governing part a little bit later, but just think that these rules are applied to be able to update the data that we are inputting onto the network. And most DLTs, no matter which they are, have some of the same three building blocks. There'll be the ledger itself. So the ledger is the ones that's holding all the transactions. The consensus algorithm to ensure that all copies of the ledgers are identical. And there's an incentive, or there's a reward for the network participants, which these nodes are processing the transactions, and these rewards are usually in the form of cryptocurrency. And that's where the idea of proof of stake comes in as well within a network. So Hedera is a DLT. It's a decentralized ledger technology, and it offers 10,000 transactions per second at a fraction of a cent per transaction, meaning that we could process a lot of transactions and it's not going to cost you very much, with the final consensus confirmation of 3 to 5 minutes. It's also EVM compatible, meaning that it supports smart contracts just like Ethereum does. In addition to that, offers some native services. Being EVM compatible means that some of those EVM developer tools that you use and frameworks work out of the box with only minimal config changes that are needed. So now that I mentioned consensus and a couple of other things, I'd like to dig in a little bit further into what I mean by that. So the Hashgraph consensus, that is what's behind the network, the Hedera network. It's its consensus algorithm, which is a directed acyclic graph, also known as a DAG. There are quite a bit of terminology in here that I will do my best to explain as I'm talking about it. And so here there's an image that you see where I try to show what a DAG means. And you can think of the acyclic part of it, meaning no cycles or loops. So think of a DAG like a map where every point or every node is connected by one-way streets and you can't go in circles. And so what this gives you is that it's deterministic. But what does deterministic actually mean? Well, I like to think of deterministic as like flipping a light switch. Once you flip that light switch on, it stays on with no changes. And then probabilistic is, imagine you're throwing a coin over and over again, and you are growing certain that it will land heads, but it's never 100% guaranteed. There's a probability aspect to it. And so in blockchain terms, deterministic means that once a transaction is marked as final, it's set in stone. It won't ever change. If you're probabilistic, then when a transaction becomes more certain with more confirmations, but it's never absolutely final. And so Hedera's consensus algorithm being a directed acyclic graph gives you that deterministicness. So once a transaction is marked as final, it's going to be set in stone and it won't ever change. The consensus algorithm has two main things that it does, and those are the two main things, and that is make sure the transactions are valid and make sure that they're being ordered fairly. You don't want things cutting in line. And for transaction validity, we use the public key cryptography. And what this means is that anyone with the corresponding public key can verify whether the signature will match a message. Now, the harder part is fairly ordering transactions. And this is where Hashgraph does something different from the traditional blockchains. It uses two protocols, gossip about gossip, which is about how we communicate this transaction data. And then there's virtual voting. Instead of broadcasting these votes across a network, which would slow things down because we're having to send and broadcast everything, each node will determine the order based on the events that it knows about. This allows you to reduce bandwidth and it keeps things very efficient. Now, I have a short video with some really cool animations that will explain that just a little bit better than I did. So let me go ahead and play that for everyone. I made sure to share my audio, so if you have your sound off, make sure to put that volume up, please. I don't think it is playing.
Yeah, no, it's not playing. Yeah.
Interesting.
Even though we tested it out and it totally worked.
Yeah, it did. Let's see. Okay, that's totally fine. So basically, what this is doing is Alice and Dave will have a message and they'll send it to different people at random. And that's highlighting Bob's transaction and Carol's transaction, two different transactions, so they're different colors. And now they're continuing to send even more messages. I think I have the yeah, so it keeps track of everything and of the time that everyone received. It's then going to organize these times and it's going to get the median, so like the middle time, to try and figure out when each message was received. And after it has done that, it's going to it's going to order them. And I'm going to just try and read what the video is saying. Okay, so this is the graph, and this is the hash graph part of it. So here we're actually mapping out all of those messages that were first sent by Alice and adding them into this graph. And then we're adding what Bob sent, what Carol sent, and it creates this really cool graph about how we talked about what we talked about. And this is the gossip aspect of it. In addition to that, each little node will have the transaction that occurred, the timestamp that it happened, that signature that I talked about, in addition to 2 hashes, which is what connects each event to the other one, which is what a transaction is. And then something cool about this is that this graph is actually on every single node. So we have the history of how we talked about each other. And this is where he talks about it being how we're gossiping about how we're talking about it, which is where the gossip about gossip protocol comes in. And now the virtual voting is something that we receive based off of already knowing what we talked about. We don't have to send receipts or send out any additional information about, well, how did Bob get the message or when did Bob get the message? We have part of the history within each node. And so this is what the hash graph consensus is. And so right here, we're going through, well, how do we get the transaction order? Well, you order it by the event. Well, what is the event order? You sort it by that consensus timestamp when you get the consensus timestamp, which is that medium received time. And then from that received time, you're actually going to only get it from the nodes that have been active. Well, what is an active node? And that's active nodes are at that time sent, there was events sent to many. Well, at that time was going to mean that during a specific round, events were sent and there was a witness. And that witness is what we considered famous. And then they take the weight of all of this virtual voting based off of the stake or how many H bars are on a node. And that was my video explanation with me on top of it. And I will share the video so you can actually hear it next time when you watch it on your own, because I think it's pretty cool how this is explained. Let me go ahead and move over to the next slide. But I have a little graphic for it. So the consensus is different from other blockchains, and this is how it differs. Most blockchains are going to use blocks as inputs, and these transactions are bundled into these blocks, which compete to be the next block added. Before a block is added, it must be validated. And once it's validated, we have a winning block, and it's linked to the previous block, and it forms this linear chain that sort of resembles a linked list. And there's a couple of other things that have to be done to make sure that we're not having more chains being built. And we have competing chains. We want to have a singular, right? So there's an aspect of having to remove, and that's why you see in the image that we have some blocks kind of cut off from the main list right here. Now that's a traditional blockchain. However, with Hedera, since it's a DAG, each node is a single transaction rather than transactions being bundled into a block. They're ordered fairly by combining that gossip about gossip protocol and the virtual voting that we discussed in order to achieve that consensus. And then each transaction is added independently to the network. This is what gives the better efficiency, as Hashgraph focuses on faster, more efficient transaction ordering without the need for any type of block competition. Well, the blockchains require time to be able to validate the entire blocks. And so this consensus algorithm looks fundamentally different from the standard blockchain. So that might leave you asking, well, is Hedera still considered a blockchain? Well, it is. And that's because every 2 seconds, it will organize its transactions into a format that looks like a traditional blockchain. That's what Hedera will do. And this makes Hedera compatible with tools and systems designed for Ethereum, such as Ethereum's coding languages, being able to use the JSON RPC. And so even though Hedera works differently and it looks differently, we have a graph, it can still be used with those Ethereum tools, is what I'm getting at. Now, how do we actually communicate? There are three primary communication protocols available. And I'm going to start with the first one, which is the Hedera APIs, which we like to call the happy APIs. The protocol that it uses is called gRPC. That's simply the protocol used to transfer data. The format that we need that data in follows the protocol buffers. And the tools that you can use in order to send this protocol buffered shaped data via the gRPC protocol is using the Hedera SDK. So that's sort of a breakdown of that first primary way that you could communicate with the network. Now there's a second way you could communicate, and that's using the Marinode APIs. This uses a protocol that most who have studied computer science or web development know about the HTTP protocol. The transport protocol for this data is HTTP, and the shape that the data is being transferred in is JSON. And you can use tools like curl and fetch to be able to create that JSON data and then send it over HTTP. And what the Marinode APIs will give you is transactional historical data of what's been on the network. If you want to get account balances, account information, you can use Marinode APIs with JSON over HTTP to get that information. And last, but definitely not least, we have the JSON RPC. And this is using RPC protocols. I wrote HTTP, but the format is JSON. It's an Ethereum-specific implementation of JSON RPC for blockchain interaction. The tools that you use here, if you have been a blockchain developer before, you'll use Foundry, Hardhat, Ethers, MetaMask. You could even use curl and fetch as well to be able to format this data and then send it over as well. And I have a picture right here of me using curl to be able to hit this endpoint, and I'm get block by number, and I want the latest number, and I'm getting returned a number here. This is a JSON, and the number is in a hex. So this is showing that I'm making a JSON RPC request. On the other side, we have a Marinode API request, also using curl, where I'm hitting the Marinode API, and I'm hitting the blocks endpoint, and I want 1 in the descending order. And here I'm getting some JSON as well as a number of that block. It looks slightly different, and these were not sent at the same time, so they're not the same block, since every 2 seconds Hedera is converting its data into blocks. And so what does Hedera offer? Well, we have multi-language SDKs. You can use JavaScript, Java, Go, Swift is also another one, Rust, C++, which are in beta, to be able to work with the network. So if you come from a more traditional web background, you don't need to learn a new programming language or learn the architecture of a smart contract. You can select the SDK that you feel the most comfortable with and easily get started with building on Hedera. If you are a seasoned Web3 developer, you can also use those familiar tools like Hardhat, Third Web, Ethers, as we're able to do that with the EVM compatibilityness. So Hedera also has the stable fees, meaning that you pay an HBAR, but the prices are fixed in USD. And right now you could do 15 transactions per second, but up to those 10,000 with the fair ordering. So there's no worries of front running or sandwich attacks or backruns as well. One of the unique features is that Hedera has these 3 main services. There's a Hedera Token Service, a Hedera Consensus Service, and a smart contract service. And with the token service, you're able to create both fungible and non-fungible tokens without the need of creating a smart contract. You can use any of those SDKs to create those. In addition, if you use a consensus service, you can create message queues with pub sub type capabilities. So you could create a topic, you could write to that topic, subscribe to it, and you can also create private or public. Another way that you could use message queues for is for like a leaderboard if you're making a game, and it will be immutable. So you can be sure that that information, that data is not changing as it's on the network. And last but not least, the Hedera Smart Contract Service allows you to create smart contracts for everything else using Solidity. And you can also use the JSON RPC protocol as well. I have an image here from HashScan, which is the Explorer, where you can go ahead and see transactions that have occurred, whether you're on testnet or mainnet. You just have to change one of the dropdowns. And here you can see that there's a fungible token that has been created. And you can see the name of it, the symbol, initial supply, and the total supply of it. And on the bottom right, we have a non-fungible token. You can see some of its metadata, sort of like as this description, the serial number, the owner, and the image as well. This is all being seen on HashScan, the Explorer. These tokens that are created through HTS are natively built in, and again, do not require the smart contracts, but they can be interacted with the EVM methods as they act similarly to ERC20 and ERC721. And I wanted to show quickly what the Hedera Consensus Service code would look like in JavaScript, where we create a topic using this topic create transaction class, and you then assign and execute. And once you have that topic, you can then use the topic message submit transaction to submit a message to that topic ID. And then you can see it over on HashScan, where you have that topic ID and you have the message that was sent, the time, the date, and the sequence in which it was sent as well. And then for the Hedera smart contract, Hedera uses the Hyperledger Besu EVM. That is the EVM that we use, and that is what enables the same EVM bytecode to run on Hedera as on Ethereum. And here you can see that there's a contract that I've deployed. There's an EVM address. It's been verified, so you can see the source code. You can see the bytecode. You can see the ABI as well. Let's see. In some of the tasks that you will do, you will be getting to experience deploying a smart contract as well and being able to see it on HashScan. So Hedera's improvement proposals called HIPs are what EIPs are to Ethereum. This is what proposes changes to the network, whether they're standards that need to be changed, informational, or processes. They go through this very similar process where it goes from an idea to a draft, to a review, to either being rejected or going into a last call, and being reviewed by council, which is the governing council, and then either being finalized or going active and then replaced. So there are different ways for community members within the Hedera community to participate and actually make changes to the network. But there's still a council review. And I'd like to introduce the council. So the Hedera Governing Council is up to 39 global organizations, which you could see some of them here, responsible for making decisions about the network's technology, the product roadmap, the treasury, and more. Each member runs a Hedera network, and it maintains the public permissioned nature of the network. And what I mean by public permissioned is that the public part is anyone can build on Hedera, and the permission part is not everyone can run a node. Only those on the governing council can run a node, and that is what makes the public permission part of the network. Some of the council activities, for example, like meeting minutes, will actually leverage the Hedera Consensus Service, which is that message queue, to notarize what went on during that meeting and publish them to the network so the public can go ahead and view what was discussed and know that that is what occurred. And you could get a copy of those by going over and looking at the topic ID that is public. And then you can see all those messages that are attached to that topic ID. Well, it did a lot of talking, and we've explored Hedera's technology. We've explored the services and the governing council. So now let's move forward and from the understanding to the actual building with some hands-on with Hedera. One of the tasks that we will be completing today is actually the first task in the activities for this Learn and Earn workshop. So if you're on a phone, I highly recommend you go onto your computer so we could go ahead and actually do some coding together. We're going to be using Gitpod, which is an in-browser code editor. For those who are familiar with Visual Studio Code, it should look very familiar. And then I'd like for you to feel free to ask me any questions or just slow down as we're going through this, as it's very hands-on and we may have people at different speeds completing different portions. This is called the 5-minute HTS token launch challenge. I suspect it will take longer than 5 minutes as I will be going through and explaining some of the code. And I'm going to want to make sure that we go through this together as well. I have a link here in case you don't have the link to the GitHub repo that I need everyone to open. I'm going to go ahead and share that. And I'm going to give everyone about a minute or two to go ahead and open that link. I'm going to change my screen. Let's see. Okay, perfect. I'm going to make sure that this is visible for everybody. Okay, if you could give me a thumbs up when you are on that page. Probably give it one more minute. Okay, let's go ahead and click on this green button that says open in Gitpod. You will need to sign in if you have not signed in, and it will be important that you have a GitHub account. It's going to take about less than a minute to get this environment ready for us. Once you're here, let's not do anything just yet. We could close these and we will walk through it together. Yeah, I could go ahead and resend that link. Let me grab it again. Here's the link to the challenge. So I'm going to do some talking as everyone kind of gets to this point. So this next section of the workshop, we will explore how to create a fungible token using the JavaScript SDK. We will be using specifically just that one. We won't be using any smart contracts for this specific one. And the first step is to navigate here. And I'm going to just give a quick overview of Gitpod. So over here on the left, maybe I can use some of my annotation. Let me see. Over here on the left, you have some of the directories and the files that are in this repository. And then down at the bottom, we have a terminal, which is where we're going to complete the majority of our activity. Okay, I'm going to assume that everyone is where we're at. So let me go ahead and get started. You're going to see that it says initialize.env file start. That should tell you that this Gitpod container has officially set up and it has everything that you need. And the first purple text that it says is please enter values requested or accept the defaults in the interactive prompts below. We're going to go ahead and accept defaults from many of these. So please stay along with me. If you accidentally mess up the container, the best thing that you could do is just restart or revisit that GitHub link, open that green button again and start from the beginning if you feel that it's acting funny. or you could go ahead and stop me. So the first thing that the prompt is asking is to enter a BIP39 seed phrase. Enter blank to generate a new one at random. We're going to do that. So go ahead and press enter, and you should receive a randomly generated seed phrase. It's going to be different for everybody's. So if it doesn't look like mine, that's fine. And what a BIP39 is, it's a method for creating a human readable mnemonic sentence. It's easy to read, it's easy to write, and it's created from random data that serves as a backup to recover your wallet. So this phrase is highly important and should be kept somewhere safe, and it should never be shared. But for testing purposes, you're able to see mine. We are going to be working within the testnet environment. So in this case, it's okay that you see mine, but you should never share this out in the wild. For the next step, we're going to go ahead and go with the default value. So go ahead and just press enters again. Oh, I see that we've got someone who has missed the steps. We just started, so simply go to the GitHub link and click on that big green button that says open Gitpod. And then for the first two prompts that it asks you, press enter. So this next prompt is asking us to enter our preferred JSON RPC endpoint. Even though we're not going to be using the JSON RPC as the protocol to send any of our data, we're going to go ahead and just press enter to leave it blank to use the default one as well. This is now asking us to enter operator account private key. This operator account is what's going to be used to pay in test HBAR for any of the transactions that we want to execute or submit to the network. We're going to use one of those three that we created, and the prompt already knows that. If we press enter, it's going to go ahead and do that for us. Press enter. It's going to say, please ensure that you have funded and then an EVM address. We need to copy that address in bold, and we actually need to fund it. And what funding means is we're going to send or grab some test HBAR, since this is the account that's paying for those transactions. We're then going to do a command click on this faucet and just say that you do want it to open the external. If you see me looking over to my left, that's because my screen is over there. Go ahead and move this. This is our faucet. This is what you can go to enter a wallet address and receive 100 testnet HBAR. So just copy and paste that wallet address, click receive 100 testnet HBAR. Make sure you do the CAPTCHA and select that you're not a robot, and then confirm the transaction. I'll go ahead and probably I'll stop for like 30 seconds and check the chat to see if there's been anybody running into issues. Once you get to this part right here, just go ahead and stay on the page. To sign up on Gitpod, you're going to need a GitHub account. So in order to be able to start up this Gitpod, you first need to create a GitHub account by going to github.com. And then once you log into Gitpod, you will be able to see this entire repository by clicking on that green button. If there's a couple of you that are having a lot of issues with Gitpod, then I suggest you stay for the office hour, which is right after this, and I could do some more one-on-one assistance with getting that Gitpod going as well. So yeah, just stay behind and I will be able to help. When you get to this faucet, make sure you don't click on the connect wallet. We're not going to be connecting a wallet to the portal at all. So just to go through it again, we would be opening this faucet. You might not be able to see the tab. You should be able to see this tab now. It says receive testnet HBAR. You'll be pasting your wallet address here, and then you'll be receiving 100 testnet HBAR. If you've already clicked it, you'll get an error saying that you have to wait a couple of hours, since you can only get this every 24 hours. So once you've funded this account, you're actually going to go back to the Git pod that we were at and just press enter. And you're going to see your terminal outputting a lot of different information, like you're checking all of the accounts, making sure that they've been created, your seed phrase, along with the operator counts. And it's going to ask you, do you wish to overwrite the .env file? Before we say yes or no, I'd like you to go over to the primary area on the left and find your .env file and click on it. So this is going to hold all of our environment variables, which are very important when developing. There's some private keys, which we like to keep secret. And so we put them in this .env file in order for them to not be in our code directly, which would be a bad practice because they could people could steal some of those private keys and then get access to accounts. So we use this environment variable to hold this information. And what we're going to say in the terminal is we're going to say yes or Y for yes. And we're going to overwrite our blank.env file with all of the information that we just set up when going through the prompts. So once you click yes or write yes and press enter, you'll see all this information fill in. Yeah, I could go ahead and drop the faucet link right here. I'll go ahead and stop for a couple more seconds. Seems like there's a couple of you trying again. So what we just did was we set up our rest of the environment to be able to create that fungible token. We ended up creating that seed phrase in order to be able to create accounts from that seed phrase. We determined which account is going to be responsible for paying for the transactions that we're going to execute on the testnet environment. And we overwrote our blank.env file to save all of that important information that we just did for us. Okay, great. All right, let's go ahead and actually dive into creating these fungible tokens. So for this part, we need to change directories. So we need to go into the source folder. So you'll change directories in the terminal by typing in cd for change directory and then src. So cd space src and then click enter, or sorry, press enter. And you'll see your Git pod workspace now says workspace / 5-minute token launch challenge / src. If you go over to your left and you click on src, you can see that there are two files in there. We have our package.json file and we have our script 5-minute token launch.javascript file. Let's go ahead and open that script 5-minute token launch. We're greeted with our imports of the Hashgraph SDK, which imports all of the classes that we need in order to be able to create this fungible token. We also have some logger information, which is simply for this activity, but not necessarily anything that you need to dive into. But on line 21, we have the beginning of our function, which is called script 5-minute HTS token launch challenge. And this function holds the code responsible for creating that fungible token and minting as well. On line 36, we're creating the client. And so I sort of briefly explained the client. The client is the point that allows you to talk to the network using the SDK. You create the client for a specific environment, whether it's mainnet or testnet, and we're using it for testnet. And we're setting the operator account, the one that's responsible for paying, by passing in the ID of that operator account and the private key as well. And that's how we get this client. Now on line 41, I'm going to need you all to start typing a name for the token that you want to create for the fungible token. So I'm going to call it Hedera test token. It's going to be a string. And then for the symbol, I also would like you to type something in. So like HTT is what I'll probably write. You can think of the symbol like ETH or HBAR. It's just a smaller version of that name that will represent your fungible token. And then the initial supply we don't want to have at 0. We want to have an initial supply of these tokens when we create them. So I want to start with an initial supply of 700. You can have an initial supply of 50 or 5,000. Just to put a number that's greater than 0, please, for your initial supply. It's definitely flexible. You can name, this is a question that's being asked in the chat, if the name and the symbol is flexible or if it's fixed. It is not fixed. This is where some of your creativity can come in. You can create a fungible token name of your choice, and you can create a fungible token symbol of your choice. For this activity, feel free to be able to choose a different one than what I have chosen. And also with the initial supply, it does not have to be 700. Just make sure that it's above 0. And once you've done that, make sure you've saved the file. You do Command S for saving. Okay, so now that we've actually set up the information that we want for creating this fungible token, we're going to go ahead and run this entire JavaScript script in the terminal. So just a reminder, make sure that you're in the source folder when you run this, or it will not find the file to run. So you go into your source folder by going to your terminal, typing in cd space src, press enter, and now you should be inside of the source folder. And to run this script, you're going to type in // and then the word script, but spell it, make sure you spell it right, and then hit tab, and it should complete the entire name of the script for you. So it'll be / script -5 -min -token -launch.js, and then press enter. You should see a flag with some green text that says, "Welcome to this 5-minute HTS token launch challenge task." It has read your .env file. It is using the account with the account number that is being presented on your terminal, and it's on the step for configuring the new HTS token. Once you've reached this point, just hit the enter or the return key when you're ready to proceed. So let's go ahead and do that now. And you should see under configuring the new HTS token that we have some text that says the token create transaction ID is the following. So we've set up and created this transaction. And the code for that is on line 48, where we've set the token type to fungible. I'll go ahead and zoom in. We've set the token name to the name that we had originally written a couple lines above. We set the token symbol as well, the initial supply, and we are freezing this transaction with the client. And when we freeze a transaction, we're saying we're not going to make any changes. We're ready for this transaction to be sent to the network, but it hasn't been sent yet. We're at the step where just the transaction has been created. The next purple line says that we're going to be creating the new HTS token. So let's hit the return key when we're ready to proceed, and let's do that now. So here we can see that the new token ID is, for me, 0.0.4950288. What happened is that the transaction that we had created and we had frozen and we're ready to submit has now finally been submitted. The operator account has had its funds removed in order to be able to pay for the transaction of creating the new token, and we have now received that token ID. All of that information in the code is on line 63. Actually, starting from like line 70 to 76. So like these right here. We were able to sign the transaction. We were able to execute it, and the executing portion is what actually sends the transaction to the network with the client. And then we grab the receipt. And from the receipt, we were actually able to grab the token ID. And that's how it was printed out here. Now, finally, we'd like to view this HTS token on HashScan, which is the Explorer. So let's go ahead and press enter now so that we get that link for that HashScan Explorer. So you'll see the new token HashScan URL. Just like we did with the faucet, go ahead and press command and then click on that link, and Gitpod will ask you if you want to open the external website, and you'll want to say yes or open. And let me share my other tab now. And here you see that we are in a HashScan. We're on the testnet environment. It is a fungible token. This is the name of my token that I decided to name it. And this is the symbol of it. Here is the token ID. There's an EVM address attached to this token ID so that it's able to be worked with if you're working with the EVM. And then we have the name and the symbol again. And over on the right over here, we'll have our initial supply of 700, and our total is still 700 since I did not mint any more fungible tokens. I only created the ones with the initial supply. Going back to our Git pod, we'll also see that that was the completion of this activity, this task. And to recap, what we did is we first set up our environment following those initial prompts, default for everything. We then went in and ran script 5-minute token launch JavaScript file. Well, before we did that, we created our token name, our token symbol, our initial supply, and then we ran the script and went through the prompts to see this creation of this token. And finally, we were able to complete the task. Now we have one last thing that we need to do in order for you to be able to prove that you've completed this task, and it's the summary metrics. So you'll need to hit the return key one more time to proceed to give you those summary metrics. So you're going to want to copy this HashScan URL to view the token that you've created, the fungible token, and the summary metrics. It could be a screenshot or a copy and paste of them. And what the summary metrics is showing you is that it took us 18 minutes to complete this entire task, including setting up our environment. And then it took us 3 minutes to complete just the 5-minute token launch challenge when we were running the script. And you could see how many errors you had prior to completion. It doesn't matter if you had any errors. It's just something that this keeps track of. And it also shows if there was any incomplete tasks. So you could go back and see if you missed anything as well. In addition to that, you'll see that there's an HCS metrics on HashScan. If you go ahead and click on that HCS metrics on HashScan link and you open it, you will see that we were using that message queue service, or the Hedera consensus service, to create a public topic and write messages of how we were going through this learning process. And this is just a neat way for you to capture part of your learning while working on these activities. And this should be on the other 2 activities that you have left to do as well. I go back. I hope everyone has enjoyed being able to go through this. I know working with code can sometimes feel frustrating if it's not working as expected. So after this, there will be an office hours where I will be here, and I could get some more one-on-one help for those that may have been having trouble completing this first task. I want to share the rest of the tasks. I want to see if I can send this. Okay. I believe that the resources for the rest of the tasks should be on the resources shared earlier today, but if they aren't, I can get those to everyone. But there are 2 more tasks to complete. That's going to be the consensus service, so you're creating your own topic, and then the smart contract one, which is where you're creating your own smart contract. And I will make sure to send all these resources that are being asked on the chat as I read right now. I want to thank everyone for their time and for being here with me. And thank you. It was a great opportunity.
Thank you so much, Abby. This was really, really wonderful. So I've linked the Telegram group specifically for the Hedera workshop in the chat. You can also find it from the Builder regular Telegram chat in the subgroups. And like Abby said, all the information will be available there. Feel free to ask your questions, and happy coding. Take care.